Hello and Assalamualaikum. My name Mohamad Ayyub Bin Mohamad Sofi. My metric number is B0191910417. I am under supervision of Prof. Madya IR Dr. Muhammad Hazli bin Abu Bakar. Today, I would like to present my final year project proposal with the title Alteration of Copper Surface by using Laser Engraving Process for Deep Pattern Marking. This is the outline of my presentation. We will start with introduction, literature review, methodology, and the last one will be preliminary finding. Okay, now I will start with introduction. Laser engraving is a technique to transfer an idea of graphic design into material surface using laser machine. As we know, people from ancient era are often engrave picture or letter on all kind of surface such as rock and metal. Evidence can be found from all over the world that are populated by civilization at that time, such as Egypt and Rome. The carved of arts are beautifully printed by the walls and building from the era. Time flying, and then the technology for engraving evolved from using hand graver to a modern way, that is by using laser. Thanks to the technology, the design that are impossible to engrave then can be done with a great detail and less time required. Okay, next we will move to the problem statement of my study. Number 1, laser engraving technique using master oscillator power amplifier, or we call MOPA, are not very familiar in Malaysia due to the price of the laser machine that are too expensive. Number 2, copper is a metal that have a very high thermal and electrically conductive and not easy to engrave. Number 3, the effect of parameter change on the laser engraved machine can affect the color, deepness, and roughness of the copper surface. For my study, I have 3 objectives to achieve. Number 1, to investigate the effect of parameter consists of power, speed, frequency, and the laser loop on the copper surface. Next is to evaluate the deep pattern marking based on the laser period. And the last one is to analyze surface quality of copper after laser marking by microscopic observation. This is the 3 scope of the study. The first one will be adjusting laser parameter of the laser engraving machine. Number 2, study the microstructure of the after laser surface as the conclusion of the experiment by using digital USB microscope. And the last one will be study the application of laser engraved on copper plate with a certain period. This is my literature review. To understand the laser engraved, we first have to know the basic of how this technology comes from. Now, there are several types of carving. The first one is engraving. Engraving is one of the well-known traditional graphic technique. The development of engrave is first to be a backup for printing on the book. Eventually, the technique become an art form thanks to its unique expressive ability. The second type of carving is etching. Etching is technology that are famous is atomic layer etching. Etching is a process of disrupting bonds that attach atom to another in order to remove them from a substrate by removal mechanism, that is chemistry, temperature, and collision. The last carving type is aquatine. Aquatine is a hypersensitive dance of shapes, color, and abstract imaginary that depicts the emotional response to intense natural setting. The main purpose of laser engraving is to engrave a design or idea onto a material surface using laser machine. When the process of laser engraving starts, to produce the high heat need to vaporize, the laser must reach specific area with large amount of energy. While laser engraving change the roughness of a material surface by melting it, laser engraving also create that gap by sublimating the substance surface. To achieve sublimation, the laser engraving system must generate enough energy to ensure that the material surface reach its vaporizing temperature in milliseconds. The material evaporate into vapor when the temperature reach its vaporization temperature optimal value and be measure the depth and width. Laser engraving technology is usually used to engrave metal workpiece such as copper, steel, zinc, and aluminium. To generate deep crevices, laser engraving sublimates the material surface. That is mean, the material surface absorbs enough energy to change from solid to gas without transform to liquid. This vaporization method needs certain temperature depending on the different type of material. An article by Dharmesh K. Patel shows that investigation of the optimization in parametric of the engraving process for various material by using a technique called gray relational. Marking and engraving is possible with a laser engraving machine by changing the input parameters such as laser loop, laser power, laser frequency, and laser speed. Next is for the methodology. I create a flow chart to make sure that I do the study with a proper way. The study starts with stating problem statement. After that, I have done reviews to the article and journal from years back about my study content. The next part is about the material that I select for the study. I choose copper as the material. The testing will be made in PSM2 with adjusting the parameter of the laser engrave machine. Finally, I will collect all the data and analyze it for the conclusion of my study. In this slide, you can see the software and the machine that I will use in my study. I will use the Adobe Illustrator as the platform to create design. Master Oscillator Power Amplifier Fiberglass, or it's called MOPA, in short, is the machine that I will use to perform the laser engraving. Lastly, I will use digital USB microscope to analyze the surface of the copper plate that I use. In this slide, show the parameter that I will adjust in my study. The first one is power. Power is the power of the laser that measure in watts. The more powerful the laser, the higher the wattage. Second is frequency. Frequency is the rate of the pulse is determined by frequency. The number pulse decrease as frequency decrease, but the energy output per pulse increase. The last one is speed. Speed is how quickly the laser moves across the mark. The faster the rotation, the less material is displaced. As you can see, this is my preliminary finding. At first, I used copper plate with 3 different thickness, 0.5 mm, 0.3 mm, and 0.1 mm. The result is shown in the picture below. The left one is 0.1 mm copper, followed by 0.3 in the middle and 0.5 mm on the right. I can conclude that copper 0.1 mm become bend and shrink. The problem with the parameter that I use on 0.5 plate are not enough for the depth of the engrave. The 0.3 is the better result among all those two. This is one of the experiments that I did in the testing session. The parameter that I use are the same as the previous one, but I changed, or more specifically, I leave the laser as continuous for about 1 minute. As the result that I get, the 0.5 mm copper plate become grayish and the depth of the engravement is greater. The right picture is the copper 0.1 plate. As in the picture, the copper plate 0.1 mm thickness vaporized completely, leaving the place that only the laser didn't touch. The plate become darker as the time passed, and the laser also go through the cement that I use as the base of the plate. That is all from me. Thank you.